Nintendo Switch. Bad port. Let me switch you over to microscope. Alright, so this port is pretty significantly mangled, which means it's probably not the only problem this switch has. All those pins shorting together tends to have secondary failures or cause secondary failures. So at the very least, we're going to be changing the port today, but it's very likely it's caused another problem either with the charging IC or the USB control IC. I'm hoping it's just the USB control IC, otherwise it's probably going to be a two-parter because I have the power ICs on order, but they're not here yet. Yeah, so first thing we'll do is change the port. We'll do some tests. We'll test the whole unit, see if it takes a charge just with the port change. We'll do some measurements around the charger IC. There's a few caps around the charging IC that will indicate once the charging port is fixed. You can't measure anything with the charging port shorting out. We'll measure around the charging IC. There's a few caps around the charging IC that usually indicate whether it's the USB IC or if they're if it's the USB IC or if it's the charging IC. And we'll just do some measurements and check and go from there. Alright, so we're going to switch to this assembly bench. So disassembly is done. Now we're going to do a visual inspection. Sometimes there is a telltale sign on the USB chip. So here is our charging IC. If you want a comparison to like an iPhone, think TriStar. And over here is our USB control IC. And unfortunately, I'm saying unfortunately today because I don't have my charging ICs in. I suspect it's going to be a charging IC problem. A lot of times when this one goes bad, I mean, we won't know until we do measurements after we remove the port, but a lot of times when this one goes bad, there's some physical evidence, and I'm not really seeing anything. Not necessarily, but we'll find out. What we're going to do is measure that capacitor right there once we've removed the port. If it is short, it's very likely that this chip here will be the problem. If it is not short, this chip is probably the problem. That's just what I've gathered from watching the videos. I've watched quite a few of the videos trying to get a grip on this repair. So this here is your charging IC. So think TriStar again. See if I can get you focused here. Yeah, think TriStar on that one. That little capacitor right here. Let me grab a pointing device here. Little capacitor right here. Once you've removed the port, because the port, as you saw on the earlier, it is mangled, so it's shorting everything right now. But once we've removed the port, we'll measure that cap right there. That'll tell us if this, which is the USB IC, is short. Not too difficult. It seems to have signature failures, which makes it pretty approachable from a repair standpoint. It's just figuring out the signature failures. So first thing we're going to do is remove this port. I will probably use some low melt so that I can get it out easier. As we saw earlier, it is supremely mangled. Yeah, that is mangled. So any measurements with that port on the board are pointless because it's shorting lines everywhere. Anyway, that's our next step. Remove the port and then take some measurements. Alright, getting started on this connector. I'm going to apply some low melt. To everything, just so it'll make it easier to get off. First on this side, and then we'll do the other side. Worked with this stuff before. A little bit of a hard time getting it on the iron. solder on these pins. Easy to get off. A little bit on all of them. All right. Joints. This thing to get this connector off. The board holder has failed me. Flux in there. Flux helps. Grab some more little melt. Just want to lower the temperature of this alloy, or make it a lower temperature alloy with the low melt. And I want to hit the other side. Let's do that other side without the board holder. It's not a good way to grab on at the moment. Get some flux. That's a big grip. Alright. Just grab some more low melts. Get it mixed in there real nice. We'll have to wick this very well because we do not want low melt alloy on the final job. Alright. I think we are prepared for removal. I do think we want to use the board holder. Hopefully I will not have to use much heat. I'll get my tweezers, which are over there on the other bench. Just set this on top. It's going to be enough weight. No, but I have something that will be enough weight. And a heat sink on top of it. Big block of aluminum. That'll work. To be able to see. I'm not real sure what temperature come in at this with, so we're just going to play around until we get it right. Appears to not be enough. Change gloves real quick. I wear one of these thermal gloves so I don't have to worry that much about which direction I'm blowing it. I mean, I can do a safe direction and not worry about my hand. Alright, so we'll add some more flux and we'll raise the temperature a little bit more. Alright, let's try again. I'm going to put a heat sink over this connector. On both of these connectors, actually. Up the temperature a little bit more. Pressure on it. Unsuccessful. I may have to put it on my big pan of ice coming up from under. Go. I just don't feel any movement. Not great. Alright, let's approach this another way. Put some more low melt in there. I don't have enough. Maybe it hasn't gotten thoroughly in there enough, but I'm also going to put it on the pan of ice and heat it from below and see if we can pull it through. Drown it. Low melt for sure on there. Not trying to save this port. That is not what I intended. All right, this should be thoroughly drowned now. Try once again with this method, and if not, we'll throw it on the pan of ice and try it that way. I'm making any progress. All right. We'll try the other way. I'll go ahead and drown these. Or did I already drown them again? Just put some more flux in it though. Alright, let's grab the pan of ice. I don't know how much of this you're going to be able to see. Come at this. expecting it to be this difficult. Up a little bit more. Very strange. Oh, there we go. Now we're starting to see a little bit of action. There we go. Finally. Check all our pads and everything, make sure we didn't have any incidents. Alright, so noting I had that at 850. Looks like we may have taken one pad. A connected pad, but we can jump it. Not that big a thing, but I would like to figure out how to do that without screwing up pads. That one's almost one to go. No, that one's okay. Couple wanted to come up, but they didn't. I may conformal coat and strengthen those. Have to be very careful about cleaning them. Scrape a little bit. It's a bit corroded. Okay. Let's put some flux everywhere. I gotta clean up all this low melt. Alright. Alright. We're going to do some measurement real quick before we put the connector back on. I've already fitted the connector, it fits right in there, so no big deal. But I want to measure this capacitor right here and see if he's short. He is not short. So that tells me the USB chip is probably fine and our problem is going to be that guy. In which case I will have to do a part 2. Well, what we'll do is we'll put the port on. I have very little hope that it's going to charge, but we'll test it and see if it'll charge. But it's definitely not the USB chip, because if it was, that guy right there would be shorted. At least from everything I've gathered. So it's probably this guy. And can you guys even see that? Let me make sure I'm doing this on camera and in focus. Okay. So this fella right here, as I understand it, if we had a problem with the USB chip, this one would be shorted. So our likely fault is going to be this guy. Now I'm going to put the port back on, solder it on, and then we'll run a test and see if it charges just with the new port. We may get lucky and it may not have taken out anything. We don't know, but it's not the most likely scenario. The most likely scenario is this guy's bad, and we'll have to wait until our chip comes in to fix it. But let's put the port back on, and we'll go from there, and we'll test from there. Alright, we're ready to do the connector. I've already placed it in there. We're going to start by tacking down the pins. I'm really hoping my micro slotting station, my micro pencil can do this job. But we'll find out very quickly. I'm going to up the temperature on it to its max. I don't want to be bridging connectors the whole time. So we'll tack down the pins first. I like to hold down the connector while I tack down the first couple. Beautiful. All right. That went pretty well. Makes me question, how the hell do we do the other pins? Because there are other pins. That we may have to hit this with hot air. Ugh, that's a challenge. Alright. Alright. So I'm going to use my preheater to try to shorten this a little bit. Shorten this process a little bit. We got the front ones soldered on. What I want to do is reflow and try to get the back ones on. Let's get this in focus. I'm going to use my preheater to assist in this, because I don't want to have to do this for very long. I don't want to end up melting plastic or anything else. I'm going to be very careful and watch what's going on. As soon as that solder starts being molten, pressing down, and coming out a little bit, I see a little bit of that plastic being melty. Pressing down. Pull away. Not real sure we got those other pins. Alright. We'll go ahead again. It just doesn't feel very solid. Not sure how solid it's supposed to feel, but it feels a little loose there. Feels like the only thing that's connected is those pins there. All right. Molten. Watching the plastic. Match up the temperature. Let's pull off here. More flux. Up the temperature a bit. Still don't feel like I'm, well, no, we might have gotten it. I'm not real hopeful that we got it there. I never saw the solder flow, so let's assume we did not get it. Up the temperature a little bit. See that solder flow, reflow. There we go. Now we're getting molten solder. Wait till they all go non-molten. Alright, I'm hopeful that we got it that time. Pins that you cannot see are kind of hard to solder. This feels a little bit better. Alright. I'm gonna switch you over as we test. I'm going to test with my little Mac USB-C charger. I'm not overly optimistic about this yet. 0.2 amp. Alright, how much are we supposed to be getting here? 0.2 amp. Alright, I'm going to find out how much we're supposed to be getting here. And I will be right back. Alright, I'm attempting to perform a test. I am going to see if this thing is taking a charge. Having a little bit of a struggle with the LCD at the moment. What I think is the LCD. Just watching Mark Schaefer do this. It looked like this was all he attached. I just want to see if it shows a charge symbol. You gotta be real careful with these LCD connectors apparently. Okay. Feel pretty good about that being in there, right? I'm gonna attach the battery. obeying the rules that you normally do. Always unplug the battery before you plug in a monitor or something. Alright. Alright, let's see. See what we get here. Meter is powering up, showing 15 volts at 0.48 amps. But I am not getting a charge symbol. So I'm getting the voltage you would expect, I think. Do some more research on that and I will come back. Okay, we're back. And as you can see, I now have a working Nintendo Switch. Turns out the charging behavior was normal. It did kind of have me fooled. I thought I went and did some research and I was trying to figure out what it should take power consumption wise, and I could not find any definitive information. So just as I was trying to take it apart again to possibly change the power IC, I hit something, it powered on. I have since been charging it all day. Is now up to 86%. I've unplugged it, I plugged it in, I powered it down, I powered it up. Everything seems to be functional, so it appears in this case it was just the port. However, while it was fooling me, I was able to do a lot of research on the areas you kind of want to look around on these devices. And I'll kind of share with you what I've discovered. It's not going to be anything terribly in depth because there's no schematics or board views or anything for this device. But let me switch you over to here. So these pictures, thanks to iFixit for the pictures. This is over here is the on the left hand side is the top side of the board that you'll see when you open up the device. On the other side is the back of the board. When the port goes bad, it could just be the port, like in this case. It's kind of unusual that it's just the port. And the port, something I did learn in the process of doing it, you're going to have to be very patient with the port. It's got several rows. Let me grab one real quick. I think we kind of went over this when I was soldering it, but might as well go over it again. It's got hidden pins on the bottom of it, which can be a bit of a challenge, and I had to do a lot of research on how to solder this thing. Let's go to microscope. All right. Find where I am here. So that back row of pins right there, let me grab my pick and I'll point it out here. When you're soldering this down, you can't see these back pins, and there's no way really to tell if you got them in. So you basically got to flow this thing in. When you're pulling it, you've got to be very patient because, yes, you can low melt all around the connector, but you can't reach those inner pins. So you got to be very patient removing it. I was a little bit rough removing it the first time. I won't be doing that again. I didn't pull anything, luckily, or damage anything, but I could have. So you got to be very patient removing this thing because you can't lower the melting temperature on these pins. And then when you're putting it into place, you basically got to flow it into place, and just kind of watch these as they flow into place. And I think what I'm going to do is probably just press down on this when I'm flowing it, just to make sure that those back pins are making contact with the board. That's just my plan. You can. Everybody has to find their own way. That's probably going to be my way. And then I'll worry about doing the anchor points and all that. But anyway, let's go back to my capture here. So my research indicates, and feel free to do your own research. Following up from the port, we're on the left image. First thing you kind of run into is this area here, which is the main charging chip. So when the pins short out, usually when the port goes bad and when it's damaged, those pins inside the port short together. And what happens is they travel up there and they either take out this chip or this one, or on the back side they take out the USB control chip, the USB-C control chip. Now, all you can really do is kind of measure around it, but usually if you measure around this one, you're not necessarily going to get an indication that this one is bad. So what I'm probably going to do is try and eliminate the other two chips as the problem before I worry about this one. This is the most expensive chip to replace. So measuring around this one, the caps on the left-hand side, or the caps all around it. Usually if you find something shorted, it's at least from my research indicates, it's not going to be this chip. It's probably going to be that one. If you find a shorted cap, one of those shorted caps on the left-hand side in this image, there's 3 little caps there. One's a really small one, one fairly big one. You measure around those and you have a short to ground. Just from my indications, from what I'm doing, it's going to be this guy right here. This may not be a 100% thing, but that's just from what I've been getting. I watched several videos on it and people measuring around, and they're like, they would remove the control chip and they still have a short, and there almost always was this guy here. So I would say these 2 chips here are your primary points of failure if the port doesn't solve the problem. With the possibility of this one seeming to be less likely. It has happened. Apparently it has happened, but it's not real likely. And you have to be real careful with this one here because of that plastic connector right to the right of it. Also, you might run into a case where the coil to the left of this chip that's blinking here is a problem. So, generally speaking, what I have gleaned from all the research is to order these 3 chips and order that coil, which you can find. Let me bring that up. So if you're not following Mike at microsoldering.com, it's okay if you're not following, but his site is a very useful resource in this business. What he does is he posts common repair parts on his site, and let me show you that real quick. So he posts common repairs, as you can see, iPhones, Xboxes, iPads. Right here, he's posted the common repair parts that he has run into with the Nintendo Switch. And you can order them on Mauser. This is the coil. These are the ports. I think these are the power IC. Another one of the chips. More. Yep, all the chips, and you can find them all there. I ordered the ports just off of eBay because I needed them quickly. And the ports are not very expensive. The most expensive one, like I said, is the uh, main power control chip. So, and that one, even from, if you order it in America, it's probably going to cost you around 13 bucks. I did one of those on Rush, so it was about 13 bucks. If you order them in bulk from AliExpress, best price I found was about $8 per unit. The USB-C ones are control chips are not very expensive. The other chips are not very expensive. Yeah, that one. No, not that one. The other one. Yeah, not very expensive. $2.88. But yeah, the power control chip is quite quite a bit more. Yeah, here we go. So yeah, those guys are a bit more. It can cost around $8 a chip on those, but worth it because it's a common point of failure. It's being revealed as a common point of failure. Let me switch you back here. Yeah, it's being revealed as a common point of failure, so it's a good idea to stock up on those. This is a very, just so far, and what I've learned, and I'm not going to claim to be the foremost expert in this thing, but so far what I've learned is this thing is very repairable. It's actually not difficult. You have to be careful with the connectors inside. I mean, it's got some very delicate um, thin wires and connectors and ribbon cables and stuff like that. So you got to be delicate, but it's not a difficult device. It's actually probably one of the easier devices or more pleasurable devices to work on that I've seen come out of like a console company. So anyway, that's about all I know on this. I will update. I will update you if I learn more. Or as far as power consumption, I do want to say on that. If you're in the 14.9 volt, 0.67 amp, or so, that's what it's currently drawing, and it's about 91% charged now. That seems to be normal. So if you change the port and you're getting this draw, rather you're getting the indication or not, because that kind of fooled me on as you saw earlier, I was not getting the battery icon, and I don't know, it was probably just a loose LCD connection or something like that that I was not getting the indication with. But yeah, but that seems to be the power consumption you want for it to charge. If you're getting that power consumption is charged, if you're getting something like that's with the charger. You can charge these on the 5 volt. It's going to take much longer, but with the Nintendo charger, you should be getting about 14.9, 0.8, 0.7, 0.6 amps. It doesn't seem to ever go much higher than that, even when it's powered on. Let me power it off and see what we're drawing off. I don't think it changed that much, but we'll power it off and see. So powered off, it's getting, it does drop quite a bit. So powered off is drawing about 14.9 to 15 volts at 0.35 amps, and that's charging. Okay? But that's with the Nintendo stock charger. You can, like I said, you can charge it on the 5-volt USB-C chargers. It's just not going to charge as quickly. To my understanding, I could be completely wrong on that as well. This is fairly new territory for me. So anyway, I hope that helps you. And like I said, I will update the information as I get more familiar with the system. I have a shop that wants me to start repairing these, and so I should be seeing a lot more of them, or at least some more of them. And I'm looking forward to it because, like I said, it was a pretty nice machine to work on. All right. Thanks for watching.